Heidi ho there, year eights, and welcome to the final video that we are going to go through for this chapter 2. Very short chapter, only 6 exercises. So let's get stuck into this last one. Alright, we are looking here at solids, and this little rule we called Euler's rule, and we'll get to that in a minute. Anyway, so what this is actually covering is a solid occupies. So we're going to describe what a solid is. So a solid occupies three-dimensional space. Okay, so they're three-dimensional looking objects, and they can take on a variety of different shapes. Okay, as it says here. The outside surfaces could be flat or they could be curved. All right, so it could be like a sphere or it could be like a dice type shape. All right. So that's what solids can be, and we're going to look at a particular type of solid, but yeah, they can be flat or curved, and the number of faces can vary depending on the properties of the solid. So a solid with all flat surfaces, so this is the key bit, so a solid with all flat surfaces is called a polyhedron, alright, or polyhedra for short, or polyhedrons for plural, I suppose. Alright, so they're the ones we're going to look at specifically, the polyhedron. So we're going to spend a little bit more time looking at that. So polyhedron, as we have just said, is a closed solid with flat surfaces, and we call those flat surfaces the faces. So if you think again of a dice, it's just those flat faces of the dice. Also has vertices. Okay, so when we're talking of the vertices, they're like the points. And if I show you maybe a quick, if I can change this. Okay, so we're looking at these points here. Okay. Alright, so they're your vertices. Alright, so I'm going to go back. And then we've got edges. Alright, so polyhedron have flat faces, they have vertices and the edges. And if we go back to this diagram again, sort of these are your edges, obviously. Alright, so they're your vertices. Alright, and then you've got your edges. Alright, plus each of the flat faces. Alright. Okay, so make sure you have got your head around that bit. Alright, so polyhedra can be named by the number of faces. Alright, and I'll, very similar to the last exercise, so I'm just going to flick forward a bit to this stuff. So you do need to have this stuff. You don't have to rewrite it again, but have it handy where you can refer to it. Alright, so the number of sides are still going to end up having very similar names, okay, in terms of all these names that you have down the sides, depending on the number of sides, it's going to be applied in this case as well. So just have them handy because you will need to refer to them. All right. Now this Euler's rule, we're going to get to that, so I'm going to skip forward. All right. So some other solids, like I said, we're really concentrating on the polyhedrons, but you can have some other solids that have the curved faces. All right, such as your cylinders, your spheres, and you've also got cones. All right, but we're not going to really focus on them in this particular exercise. All right, the ones we are going to focus on are these ones. So a cube, for instance, is an example, is a hexahedron. So it's got, if we go down back to here, 6 faces. So if we've got 6 faces, it's a hexagon. All right, so we use that again to name these solids. All right, it's really important you get your head around that. Sorry, let me go back here. All right, that you get your head around that. Now we look at the number of faces that it's got, not the number of sides that you did with that last one. Number of faces, but you still give it the same name. So it's a hexahedron. All right. Now, if we have a rectangular prism, I suppose, so a cuboid is a common name used for a rectangular prism. Okay, so it's got a rectangular face at the front, not a square face like these guys, because all these sides are the same length. But we call this one a rectangular prism. All right, but still a hexahedron as well. All right, because it's got the six faces. All right, if that makes sense. Oops, sorry. Slight little technical glitch, but we're back on track. All right, next slide. So let's get to this Euler's rule. All right. So what I want you to do really quickly is you can just do this on a bit of scrap of paper. I want you to look at each of these shapes here. The tetrahedron, 3 faces, tetra. The hexahedron and the pentagonal pyramid. So pentagonal means it's got 5, is it? Yep, the 5 faces. And what I want you to do is count the faces, the vertices and the edges. Alright, so the faces on each one, the edges on each one, and the vertices on each one. And then what I want you to do is fill in these numbers. So how many faces on each one, So you might have the tetrahedron written here. Okay, don't worry about the drawing, you don't need to worry about that. Just count how many faces you've got, okay, in the tetrahedron. Same for the hexahedron. Count how many faces that one's got, how many vertices the tetrahedron has, how many vertices the hexahedron and the pentagonal pyramid, and same for the edges as well. Then what I want you to do is add the faces and the vertices, these guys, together, okay, and get a total in there, and we'll have a look. Alright, so I want you to quickly pause and have a quick go at that, and then come back when you've done. Okay, welcome back. Hopefully you've gone through that process. As you can see, a bit of magic has just happened while you paused, and I've filled in these as well. Alright, so as you did your counting, you should have found that the tetrahedron, for example, had two faces at the back, okay, one face at the front and one face underneath at the bottom there. Alright, so that's 1, 2, 3, 4 faces all up, okay. How many vertices it has, so that's the points. So we've got one vertice there, 2, 3 and 4 at that back face, back corner as well. Alright, so we've got 4 vertices, then we count the edges. So we've got 1 edge, 2 edge, 3 edges, 4 edges, 5 edges, 6 edges all up. Then we add the faces and vertices together, okay, and we get 8. Alright, now we do that, I'm not going to go through each one because that's going to take too long. Hopefully you've got these same ones. So the hexahedron has 6 faces, 8 vertices, 12 edges, and then pentagonal prism has 6 faces, 6 vertices, 10 edges. Now when you add these up, look at the totals. So you've got 8 and 6, 14 and 12, 12 and 10. And what do you notice each time? Okay, each time that when you add the faces and the vertices together, it is 2 more than the edges, or the number of edges is 2 less than the total number of faces and vertices. Alright, so that's where we get Euler's rule. Alright, if we go back, sorry, just bear with me while I try and get this back. That's how we get this rule. Okay, so the number of edges is equal to the total number of faces and vertices added together minus 2. Alright, and if we go back to this one, again, if we add our faces and vertices up, we might rewrite that. What is it? F plus V minus 2 equals F plus V minus 2. You can see that when you add the F and V together, in this case for the tetrahedron, it's 8. Minus the 2, we get 6, and that gives us how many edges we've got. So you can use that rule to calculate missing either faces, vertices, or edges. If you're missing, only if you're missing one of those values. If you're missing more than one of those values, you can't use that rule, it doesn't work. But if you're missing the vertices, then you can use the number of edges and faces you have to calculate the number of vertices. If you're missing the faces, excuse me, then and you still have the edges and vertices, you can manipulate and rewrite this equation a little bit and calculate the number of faces and so on. Alright, okay, so that's Euler's rule. That's basically all it is. Okay, really, really simple. So, a couple of examples I want you to do is first classify these solids by considering the number of faces. Alright, so for example, if it was an 8-sided face, it would be an octahedron. So you want to go through and label or name each of these 3 solids. Alright, that's the first thing. Then part B, you need to name these solids using a type of prism or pyramid. Alright, such as a hexagonal prism or a hexagonal pyramid. Okay, and you'll basically look at the cross-sectional face. So for instance, if we're looking at this solid here, you're going to look at this front face. Okay, so this front face, or I'll see on drill, that front face there is going to give you an indication of what type of prism or pyramid it might be. For this one, you're looking at this top face is going to be what you use to try and work out what the name of or the type of prism or pyramid it happens to be. And for a this last one, I'm trying not to give it away too much in this case. Again, you're looking at the bottom shape, all right, of that particular solid. Now there is some information, or there may not be. I thought I did put some information. Okay, well there it is there, down the bottom. I don't know why I've put it down the bottom, but anyway, it should be up a little bit further. So yeah, quickly go through this because you really need this to answer those questions. So prisms are polyhedra with 2 identical ends. Okay, so these ends are the same. So this end, and if we were around this back side here, that end are exactly the same. And the ends define the cross-section, or the cross-section part of the prism is also its name. So if we cut this in half, it's still going to be the same face at the front, I suppose. It's going to have the same shape, and that is the shape that determines its name. So in this case, we've got 1, 2, 3, 4, 5, 6 sides. Okay, if we go to our table here, 6 sides is a hexagon. Okay, but when we label this particular shape, we're going to call it a hexagonal prism. All right, does that make sense? All right, so that's all you got to do for the prisms. When you got pyramids, you look at the base, okay, with the base face, all right, and then all the other triangular faces will meet at the top at the same vertex point, and they are named by the shape of the base. So you might have different shapes for the base of the pyramids, and in this case, because it's a square base on that pyramid, it's called a square pyramid. Alright, so using that information, I know I've rushed through that a little bit, but hopefully when we go through the examples it'll make sense. I want you to have a go. I really don't know why I've mixed those slides up. Anyway, have a go at first naming these solids and then trying to name the type of prism or pyramid that they are. Alright, so pausing it now and off you go and have a go. And hello and welcome back. Alright, and again, the magic of media. We've got some answers already up here, so I'm not going to muck around too much. So hopefully you sort of were going back and referring to this as you work through these. All right. So hopefully you said this one because it's got 6 faces. All right. So it's got 6 faces, 2 at the top, 2 at the sides, 2 at the ends. That's going to be a hexahedron. 6 faces being a hexahedron. Next one, you should have counted 7 faces. So we've got 2 at the back, 3 at the front, that's 5, plus the top and bottom, that's 7. So 7 faces, if we go back here, is a heptagon. But we call that, because it's a solid, a heptahedron. And then our last one, we've got a triangular shape here, or a pyramid. So we've got, how many have we got? 1, 2, 3, 4 faces, triangular faces, plus the bottom is 5. So 5 is, as we see here, the pentagon. All right, we don't call it a pentagon, we call it a pentahedron. Okay, all right, so that's the first part. Second part, name these solids as type of prism or pyramid. So obviously this first one here, we call that a rectangular prism, because that's what it is. It's got a rectangular face. This one's got a 1, 2, 3, 4, 5. It's a 5-sided shape at the top. Okay, so we call that a pentagonal. 5, remember, is pentagon. So it's a pentagonal prism on that one. And this one is pretty much just a square-based pyramid. All right, and that's all you need to say for it, is just a square-based pyramid. Okay, because we name the pyramids by the shape of the base. All right, nice and easy. Last little thing, let's do this really, really quickly. Use Euler's rule to find the faces, number of faces on a polyhedron that has 10 edges and 6 vertices. All right, so if we remember this rule, E equals F plus V minus 2. All right, so we might rewrite that. E equals F plus V minus 2. I want you to again pause the video, think about what you've got here, put these substitutes, a bit of algebra here, substitute the values into the equation, move your values around a little bit. I'm not going to give you too much, we did do that last year, and see if you can find out how many faces that this particular polyhedron might have. All right, pause it and off you go. Okay, welcome back and let's get through this. All right, so we need to move and manipulate this equation a little bit, but first we'll solve what we can. Okay, so if you had it substituted correctly, the number of edges here is 10, so that's got to, instead of writing the E, that's the number of edges, we are now going to write 10. And we've got the 6 vertices, so instead of writing the V here, we're going to write the 6. Okay, so you should have substituted them in to begin with. Then we can work this bit out. So we've got a 6 minus 2 over here. So this other stuff we haven't changed, so the 10 is going to remain the same, the F is going to remain there, but then we've got 6 minus 2, which is 4. Okay, so we're going to have F plus 4. Now, if you remember your algebra, what we need to do is we need to make F sitting on one side of the equal sign on its own. So to do that, we're going to move this 4 to the other side of the equal sign in this case. And if you remember, when we move something from one side of an equal sign to the other, it always does the opposite. So in this case where it's plussing, it's actually going to minus on the other side. All right. And when we do that, we've now got 10 minus 4, which is 6. So the number of faces that we have on this particular polyhedron is 6 faces. All right, that simple. All right, that easy. Now that try and say that again. Manipulation of the equation might take a little bit of practice to get used to again, but we did do that a little bit last year. You might find another way to maybe work with that, but I'll leave it up to you. But I really think you need to try and get back into that algebra habit, because we are going to do algebra soon anyway. Alright, so hopefully that all makes sense. That's Euler's rule and solids, and looking at particularly at polyhedra. So yeah, that is all. Going to sign off on this particular unit and get yourselves studying, ready for the test, and good luck. Come and see me if you need any help with anything. Bye bye.